I just got this curious looking item in the mail from AliExpress, all the way from China. It took its sweet time getting here. It's been about 45 days since I placed the order for this. So I guess long shipping times are one of the costs of getting something for a lot cheaper than you might get it from a US warehouse. And this particular item actually is something I had trouble finding from a US warehouse. So getting it from China was basically my only option. So I'm going to talk you through what this is and why I got it. Here I have a TS100 soldering iron that I got recently. I haven't even used it yet. It's brand new in this nice blue finish. And this is a great little soldering iron people have reviewed online. I will not vouch for, well, I've heard that it's great. I can't vouch for its quality because I haven't tried it yet, but from what I've seen, it looks super convenient. And notably, it has a small microcontroller in it, and it's digitally controlled. It's got temperature feedback, obviously. The heating element's directly inside this soldering iron tip, and it's not very expensive. I got this one for a little more than $50. And I guess one difference between this soldering iron and a typical one, like my other one is a Weller soldering station, is that this one's self-contained, but it doesn't come with a power cable. And when you get a soldering station, typically you have the base that plugs into the wall, and then the soldering iron is on a nice heat-resistant cable. So I'm going to have to find a cable or make a cable for this one. And it has two different inputs. One is a micro USB connector that just powers it for programming. It doesn't actually turn on the heating element when it's powered through the micro USB connector. The other one is a barrel jack, and on Mini, the company that makes this is called Mini, or they at least designed it. I think these might be made by multiple manufacturers, I'm not sure. They're branded differently depending on where you buy them, but they call this jack a 55-25 barrel jack, and I take that to mean it's 5.5 millimeters outer diameter and then 2.5 millimeters pin diameter. So I'm going to get a barrel jack, a plug that fits this jack. Oh, you can see it here. DC, let's see if you can see that. DC 5525, and then it's marked as center positive, and we see the TS100 label there. So the positive lead will be in the center. It'll be 5.5 and 2.5 millimeter jack, and those are pretty commonly available. And on the other side, you can see the voltage rating. So this is rated between 12 and 24 volts, and the power you get out of it depends on the voltage you put in. So one option would be to plug this into a wall adapter, but I have so I have two different large Makita drill batteries, and I thought, wouldn't it be fun if I could power this from an 18-volt drill battery? And so that's where this curious item comes into play. My plan is to power this TS100 soldering iron. So it's rated up to 24 volts, but I'm planning to try it on 18 volts and see how it does. I want to power from a Makita drill battery. I have two of these lying around, and they're each 4 amp hours. They come up to 5 amp hours. And so this should give you a lot of runtime for a soldering iron. So I bought these, the part, finally we can get to talking about it. So this is called it's listed under various terms. A lot of people list them under like DIY for Makita battery adapter, or something like that. This one's marked for Makita or for Mac 14 to 18 volts. So Makita batteries, it says lithium ion battery, output 5 volt, 2.5 amp max. And there are several of these. I was looking on Amazon. There are different versions of this available. Some just have USB ports, and Makita makes an official one that just has 2 USB ports, and I think it might have a light. What I really wanted was this barrel connector, and I think that this one puts out a regulated voltage. I haven't tested it yet, but my plan is I don't really want 5 volts or 12 volts, whatever's coming out of this regulated port. I want the raw battery output because this soldering iron has a regulator in it. So I'm going to open this up, see what's inside, and if there is a regulator on this DC barrel jack, I want to bypass it so that we get the raw battery voltage out. So this is a Makita battery. On the Makita tools, this looks almost like the official, the bottom of like a drill. It is missing the little rubber inserts in these like little cylinder pieces that the real tools would have, and those are little bumpers to keep the battery from vibrating. But the contacts are in the right place, and it just slides on like so. And the battery has this clip that prevents it from releasing. So this thing is a nice form factor. It fits on top of the battery neatly, and it has a belt clip if you are so inclined to wear it around. And there's this little loop here, which I presume is to hold it on some kind of lanyard. The outputs would be on the bottom if you were wearing this on a belt clip, 2 USB ports and a DC port. So let's check the output. This battery is not fully charged, but it's close. I have my multimeter here, and let's just see if this thing's putting out any voltage on the barrel jack without any load on it. Obviously there's no it looks like there's no electronics in here to talk to the battery. I'm pretty sure these batteries will put out a voltage regardless of whether they're plugged into an authorized tool. I don't think they have any kind of DRM or safety check to see if the tool is the right one. But if they do, we would have to bypass that. So I'm going to be very careful here, and because I don't want to short out the output, especially if it's not protected or if we're on a DC regulator. But just, oops, ooh, it moved a little. So just holding the my one lead on the outside ring and another on the center pin, I'm getting 12.38 volts, center positive. So that suggests to me that, so this is an 18 volt battery, suggests to me that this is on the output of a regulator. It'll probably sag if we put it under load, but I want that to be unregulated, so we're probably gonna have to change some stuff up in there. Another thing I can test is whether the USB ports are putting out the right voltage. It's a little scary to put a probe down in the USB port, so I might wait on that. Let's take it apart. At the end, we can, when we're doing the modification for the TS100 soldering iron, we'll check the outputs of those. But I'd like to have some kind of cable or USB port tester rather than just jamming the multimeter leads in there. And since these aren't under load right now, the reading I get probably won't be that accurate anyway. So let's go ahead and take it apart. I'm going to take it off the battery, obviously. So it releases, when it's on here, it's a little wiggly. Like the rubber bumpers would help it wiggle less, but the ones I saw online in photos, the various different versions of this didn't have the rubber bumpers. I think the official Makita one might have, but this one is definitely a knockoff. And they're actually, if you search around, I got this from AliExpress. Like I said, it took about 45 days to get here. This was $15, which actually isn't all that cheap compared to, buying a part like this from a US distributor, but this actually wasn't available from any US distributors with the DC port. I saw ones with the USB ports, but like I said, it didn't have this barrel jack output, and that's what I really wanted. So I did have to go directly to the manufacturer. So it took a sweet time getting here, but it did arrive. So I'm just gonna use a long Phillips screwdriver down in here. I have no idea what's in here. I haven't opened it before. I did get 2 of these because I knew I would be waiting for it to come in the mail. It took even longer than I expected, but that way if I mess this one up or if I want to use it unmodified, I'll still have that option. These also come in black, and I opted for the cool blue color. It's not quite the same as the Makita blue, but I have a blue theme going on, so gotta keep it going. Okay, so loosening the screws, one came out, the other one feels like it's a little bit fetched up in plastic. All right, I think it's loose enough. So this is one interesting thing about the construction that I don't like, I should say one negative thing, is that this clip seems like it's anchored on one side, and then we have a piece of this side of the housing coming over and touching the back. And this is a super awkward mold part here. It comes down to a thin point. Plastic doesn't like to come to a sharp point like that. And also, if it's on the base of this clip, it's clearly going to weaken it to remove the supporting material. Where it's solid on this side, it's totally, this is like for, I guess, preventing this from opening too far, but maybe just for aesthetics. So that's an odd decision. But let's see if we can slide it open. Let's see what's inside. Okay, a little cracking sound, maybe some glue, not sure. See here. So another thing to note is that the DC jack, the barrel jack, is right across the separation line here, the mold line. And normally, like in this kind of clamshell packaging format, you don't really want something that spans the seam like that, unless it's, usually you'd put a plate in after the fact, and that would hold something like this that's in a hole that spans the separation. This is kind of an awkward arrangement to have it right across the gap. I don't think this can just come out on its own. I would imagine it's part of the circuit board that I can picture going across here. So at the risk of damaging this, I'm going to try to pull on it a little. Let's make sure that screw is all the way out. Surely it's not longer than that. Okay, so this is wiggling apart, and looks like there might be some adhesive in there. Can't tell. So it's coming. Oh, it's just a very tight fit with the circuit board. Okay, so it's coming apart now. Interesting. It's very complicated on the inside, more than I would expect. But there's one half. This half doesn't have any of the components. And then the components sort of span the two halves. Again, normally I would hope to see them sort of on one side or the other, but in this case, it's not how they designed it. I'm going to assume this doesn't have any stored charge in it. It's only an 18-volt power supply, though, so it's not the end of the world if it does. And like I said before, normally you don't want to see something that's panel mount across the gap in the housing. Here, you can see that we have the gap in the housing, and then this is a panel mount barrel jack with a nut on the back, and they've tightened it down until it's basically flush with the thickness of the plastic. But I think they've used a little bit of glue to retain it better because it's right on that gap, which is a little bit unfortunate. So it's a silly arrangement to try to screw this in, and then they couldn't have screwed it in after the case was assembled. They have to have screwed it in before, like tighten the nut before putting the plastic together. So very odd. And based on the sort of white film on the nut, it looks like it was super glue. I want to see if I can get that apart. It's tight in there. If it was some kind of ABS cement, then it would have melted the plastic a little bit. I'm not sure what this plastic is. I think it's probably ABS, but I haven't confirmed yet. Okay, let me see if I can... Ooh, interesting. Okay, so this, you can get a preview at the bottom there, some inductors. This yellow plastic piece is wiggling. I think it's probably... It's wired in as well, so I'm not going to break something by wiggling it, but I would like this whole unit to come out together. Let's see if I can break the plastic there. I'm going to use a tiny screwdriver and see if I can chip away. It's getting a little wigglier. Let's see, I might be able to rotate this retaining nut, but the glue makes me think I probably can't. Yeah. So a most inelegant way to fasten this together. Oh man, they made that as hard as possible. Another weird thing about this whole arrangement, it seems like there's plenty of space given how small USB chargers can be, but then they've put this capacitor hanging off the edge of the PCB as like an afterthought. So it makes it seem like they were constrained for space, but hard for me to believe given how much space is left over inside this plastic housing. Let's see here. That is really glued in. Okay, I'm gonna try to pry it out a little. I'm gonna get a little bit of a thicker screwdriver, and let me zoom in for you here. So I'm just gonna use the strong part of the plastic here and then lift up underneath with the screwdriver. See if that'll help. Oh yeah, all right, that broke it free. Okay, so there's no particular orientation, it's a circular jack, so I'm not gonna keep in mind which orientation it was in. You can see the glue residue in here. I think it was probably glued on both sides and then they slid the case together. Here's the empty battery adapter housing. You could put something else in here. Obviously this one's cut out for USB ports. If you wanted, you could sort of chop this out and put other ports in here. But I'm using it for the DC port, so I can leave the USB port in there. All right, so now we're down to the circuit board, and let's take a look. So we have this yellow battery contact unit, and it is wired under here in the center. So we have B plus and B minus. Things are nicely labeled on here. Let's see if there's enough room, I can slide this out a little. What is holding that? Looks like the wire's a little pinched, maybe. And generally, I think, when you buy these off-brand, this one doesn't even, I don't know what brand it is. If you buy one of these adapters and you're gonna plug your phone into it, it's a really good idea to check that the output is actually regulated, not just fed through a resistor or something. So we might be either pleasantly or unpleasantly surprised by what we find in here. I do not know what is holding this down. Feels like it's binding. Yep, the wire's not particularly flexible. Oop, I'm off frame there. Oh, there we go. Those are just kind of sturdy wires. Okay, so later I'm gonna have to tuck that back in, but let's take a look at what's going on in here. They spent a lot of effort trying to keep this circuit board low profile. The inductors framed in routed cutouts. Interesting approach. So we have battery plus and battery minus coming in. There's a big ground plane across this whole board. You can see the little vias that go through it. Battery plus comes over here along this thick trace. It's nice and thick. And then it's distributed to presumably something on the other side of the board, which we'll look at in a minute. Battery minus, if I move this DC jack over a little, you can see that battery minus comes in from the battery contacts, and then it's connected to this whole plane. So we have a nice big ground plane here. We have a capacitor embedded in the circuit board there on a very thin PCB like arm, and then like a little barrier reef. And then we have one over here, and then obviously this one that's just tucked in, like clipped on the side after the fact. Very odd. That one's rated up to 35 volts. They're all electrolytic capacitors, so it matters, the polarity matters. These two are written on with gold writing and are rated to 35 volts, and then we have a 25 volt one over here, so maybe for different things. So I'm going to swivel this battery contact unit out of the way. Try not to break the wire, although I could just resolder it if I need to. Okay, so here's the top of the PCB. We have two USB ports, and the barrel jack, it's not just wired to the outputs of the battery terminals. It's wired to presumably the output of this capacitor, which I would imagine is a decoupling capacitor. And if we look at that capacitor, it's hard for me to see. Let's see here. Ah, I see. So this, I don't know if you can tell, there's the two different traces are separated in the middle right here. So the negative trace is connected to the ground plane. The positive trace goes to the positive wire of the DC barrel jack. So this capacitor is just a little bypass capacitor decoupling the output. So it's rated up to 35 volts, which is good because we're going to drive it up to the battery's output voltage, which is about 18 volts. So we can keep that in there just to reduce ripples coming back from the powered item. Okay, so let's take a look at this side. We have some active electronics on here. I'm going to hold it up to see if I can see what these chips say. Oh, that is totally out of focus. Let me take it off frame real quick and see if I can see. Okay, so apologize for taking it off screen there. This chip has no writing on it at all. Presumably some kind of off-the-shelf microcontroller programmed for, I have no idea actually what they would be using it for, if this is just a voltage regulator. We do have these U3, U4. I presume that we have two different regulated circuits on here. So there's a 5-volt output for USB, and then there's also the 12-volt regulated output on the barrel jack. And I presume that these two different active components would be regulating, one regulating the 5-volt line and the other regulating the 12-volt line. And I would presume also that these inductors are for filtering on the two different supplies. So let's see if, here we see this is labeled minus, this is part of the ground plane. I don't know if I see, let me see here. So the output, positive output is coming through this via right here, and that's the output. Let me see if we can get a little closer here. That's coming through this. What does that guy say? Might help if I, R10, I see, it's not upside down. So R10 here, let's see, we have a tiny resistor. Is that a current sense? R030, is that what that says? Yeah, maybe a tiny current sense resistor. Hard for me to tell. And that's going to the output of this inductor. So it looks like we might have this side, looks like the 12-volt regulator. And I imagine this side would go to the 5-volt supply. We have plus and minus labeled here. Let's look at the other side. This side's plus. Coming over to this capacitor. That doesn't look right. That must be minus. So this is labeled plus. When I look at what this via is connected to, I see. There's a gap here again. Oh, it keeps getting me. Hard to see. Yeah. All right. So there's a little bit of solder here covered the solder mask. So this is a positive pad going. So we have plus here. This is presumably about to go to the USB output. Let's see if we can see it. Yeah, so the trace just comes right over here and goes to the positive pin of the USB port. So presumably 5-volt regulation there. And the trace takes a sharp right corner at 90 degrees and comes over to the other side. Sorry, I'm moving this battery clip out of the way. And yep, to the other USB port. So these two USB ports are sharing the regulated output from this left half of the circuitry. I can't say I know exactly what's going on here. It looks like we have, I'm surprised by the size of these inductors. I'm gonna take a look at the chip to see these tiny chips. See if I can see a part number. Better light. All right, let's take a look. Much better. So CX8825 DC 1947. And then the center component, maybe you can see the writing there. That center component is labeled 6413 BAHE1A. So not exactly sure what that one is doing. 3 of its pins are shorted together, and then the other is separate. Looks like it might be some kind of, it's labeled Q2, so maybe some kind of transistor. I don't know if this helps you see the circuit a little better. Okay, great. So for our purposes, it'd be interesting to take a look at exactly how the circuit is designed, but it's going to be very easy to modify to do what we want. All we need to do is move this barrel jack over to tap the battery contacts, the output of the battery. I'm not sure if this has any sort of undervoltage protection. I imagine the battery pack does. The battery pack is pretty smart. It has the little star, which is supposed to indicate that it's advanced circuitry, somehow protected. So I presume, this thing knows its own charge level. I presume it knows if it's going into the undervoltage regime and it will stop its output, but that would be good to confirm. I don't plan on running it completely flat, but it's something to keep in mind if you're using the output of directly from the battery terminals. You don't want to run the battery below its minimum voltage if it doesn't have any undervoltage protection. Great, so now that we have seen inside this, looks like it'll be super easy to solder these contacts over. Get the soldering station set up, we can go ahead and modify it. And we're back. It's a little bit later than I thought it would be, but time to finish up the soldering. And so I've got my board mounted in a vacuum-based Panavice Junior, and just to hold it off the piece of scrap wood I have here. And fittingly, I'm going to try soldering it with the TS100. So unfortunately, this power supply isn't ready yet. So I've dug up a power supply with a barrel connector from my internet modem, and I'm going to plug in the iron. I've never used this before. We're going to see how it works. Let's go ahead and plug it in. Gives us a nice little boot animation, and it says press. So I'll press the button. All right, looks like it's heating up. So this is a 12 volt, 2 amp supply. So it'll be good for about pretty low. So it's like 24 watts. This is gonna probably draw a good amount of current from it. Hopefully it won't strain it overly much. All right, and I prefer lead-free solder. So I have my old rosin core lead-free solder that I got from SparkFun years ago. Let's see if this can handle it. So first thing we're gonna do is desolder the existing connection. And I can smell this. It smells hot, but who knows how hot it actually is. One thing to note about this iron is, I guess it says it's 300 degrees Celsius. So this iron, since it has a barrel jack, a DC barrel jack, it doesn't have a grounded tip unless you connect this grounding wire. I'm not going to worry about that for this circuit, but it's something to keep in mind if you're soldering on a circuit that's connected electrically to something, or if you need to be careful about electrostatic discharge. So I'm going to go ahead and heat up this wire and see if we can pull this connector off. Might need to make this a little hotter. I'm going to go ahead and tin it first to see if we can get a little bit better thermal coupling to the solder on the joints. It's not even taking this solder. I wonder if it's not hot enough. Oh, took a little. There we go. I'm just going to go ahead and tin it all over. This is rosin core solder. The smoke is from the flux. And lead-free solder tends to be a little harder to work with because it has a higher melting point due to the lack of lead, but I really like knowing that I'm not handling lead all the time, especially in the house. Still not wanting to desolder this pin. So one thing to know is that, given that this power supply is somewhat anemic for this iron's desires, we might have trouble heating up this wire enough to desolder it. Let's try again. The tip is holding at the same temperature though, so I can feel the wire heating up. This could just be that this is a giant pad. There's a lot of thermal capacity on here. We're continuing with the wire too. So it does matter that this heats up relatively quickly. So I might need to turn this up a little bit. And I have no idea how to use it. Let's try holding down a button. Okay, so let's see if we can go up a little higher. Oops, okay. The menu seems pretty intuitive. I'm just gonna try leaving it alone. See if it climbs. Yep. Okay, I'm just going to leave that blob of solder on the tip See if we can hit that wire and get it desoldered. Got it. All right. Yeah, it took a lot of heating, but that worked well. I'll do the other one. So I'm just going to tin this again with a little more solder. Keep this wire out of the way. Just applying steady pressure. That one was very easy. So clearly it's just because of the heat capacity of that ground plane. And there's the cat in the background. She's just as excited as we are about desoldering this connector. Okay, so now I don't have a stand for this iron, so I'm just going to hold it. So all I'm going to do here is solder this connector back on to the battery plus and battery minus terminals. And the wires already look like they're pretty tinned, so we might have the same problem here with the ground plane absorbing a lot of heat, but we'll see how it goes. And there's some risk that I'm going to desolder this existing wire. I prefer not to, but we'll see how it goes. Let me get a little more solder on the iron. All right, here we go. I'm going to keep it on this side if I can, just to lower the risk of shorting. And this is where having an extra set of hands would be amazing. Let's see here. The iron's not quite hot enough or I'm not letting it adhere enough to the pad to reflow that solder. Oh, that might do it. No. Let me see if I can't melt this a little. I think I'm just not getting good thermal contact with that wire. I'm going to straighten out these cables real quick so that I have a little more room to hold this without burning my fingers. All right, let's see. Hi, kitty. Okay, so let's go ahead and try this again. My cat is trying all manner of meows because it's playtime. So after this project, we'll be playing with her. That pad, the ground plane, is just absorbing everything this iron's putting into it, so it's going to be kind of tricky. The iron says it's staying steady at 350 Celsius. Let me see if I can get a little fresh solder on here so I have some flux. Oh, there we go. That's adhering nicely. Let's see if I can scoot this lead in while it's molten. It looks kind of like a cold joint. I want to make sure that this gets a lot of heat. There, that looks pretty good. So ideally you want the conductors to touch. Solder is conductive, obviously, but it's not a great conductor compared to the copper conductors we have in this wire. So this isn't going to be, this is going to power this soldering iron, which seems to be working fine on its current little 24-watt supply, but good to make room for plenty of current capacity, just in case. Let's see if I can, am I still on the frame here? I'm going to rotate this. My vise came unstuck from the melamine scrap wood that it's sitting on. Jank on top of jank. Okay, so there's the wire desoldering, just like we were afraid would happen. So I'm going to try to solder that back into place. If this is going to prove too difficult to hold everything, it's possible that I could splice the wires together, then solder the spliced joint back onto this PCB pad. But for now, I'm going to apply a little pressure to the whole assembly to get this wire to scooch down here. See if I can melt it onto there. Scooch it over a little, okay. And that's a little janky, but we'll take it for now. And I'd like to put this conductor over here. So I'm going to rotate the piece of plastic in my left hand, try to get that wire to move over. I'm sure there are more direct ways to do this, but this is me being a little lazy. Okay, I need to tin this iron again. Let's see if we can do this. Don't want to overheat the pad on the PCB. Okay, so technically this is soldered, but it's gross, so I don't love it. So what I'm gonna do is, I'm gonna grab a little screwdriver and see if I can push this wire over while I'm heating the pad. Gotta be careful with, the temptation sometimes is to apply, like to grip the wire with like pliers while heating it to move it over, and it's easy to squish the insulation, especially if it's not very heat resistant insulation, like just standard PVC. So I've accidentally crushed insulation on wires while I'm trying to solder them. This insulation seems like it's pretty good, but I try to be gentle with the wire while I'm heating it, because it the insulation gets a little bit more fragile. Okay, so I have the connector wire soldered down. Looks like a pretty cold joint. It's not great. And then I'm going to try to hold this wire where I want it. See if I can get it where I want it. It was nice that the other pad didn't completely desolder like this. It's quite a mess. Let's see if I can bend the wire. What a novel concept. You want everything to be sitting where it's going to end up, if you can manage it. Just because when you melt the solder on, you don't have to try to fumble pushing things around with the iron, like I'm about to do. And as you try to lift the iron off, if things spring out of position while the solder is wet, then it's gonna be hard to get it in the position you want. So I'm not following my own advice here. Let's see. And of course things get very hot when you heat them. Here we go. That does not feel like it's sticking. All right, here's what I'm going to do. I'm going to make a bigger blob. Because why not? Keep digging, you know? Float on there for future generations to open this up and cringe. Okay, now I'm going to melt this blob. And just try to tuck that cable in. Or I should say wire, it's not a cable. Okay, that's looking promising. Great. There we go. Okay. Whew. So maybe the horror is over. Let's see. And this iron, so it's performed well. I don't blame it for my fumbling solder here, because I just was not at all holding things correctly. The iron supposedly will turn itself down if it detects that you've set it down. I'm going to turn down the temperature a little, just so that just to take it easy on the iron a little bit, although I think it can handle this fine. I'm curious what other things it can do, like what these buttons do. So far, if I hold the buttons to one side or the other. I adjust the temperature, and I clearly have not read the manual, so I wonder if double tapping, no. Pressing together, no. I'll have to get a stand for it as well. Right now I'm just keeping it in my much larger Weller soldering station stand. So it almost falls through, it's so tiny. Okay, so let's take a look at the solder job. I'm gonna hold it up real quick. Okay, so there's a gross little Hershey's Kiss kind of effect going on there that I'd like to fix. So I'm just gonna take it out of the vise now. The vise is kind of in the way. And famous last words. Tin the iron again. Skipping steps here. This might not be hot enough. But I think perhaps before it just needed tinning. So hold this wire in place. It's going to get really hot while I melt the solder joint. Yeah, I think I need to make it a little warmer. So convenient to have it right under your thumb. That's awesome. So I've only ever used the big plug-in soldering stations and the very horrible, cheapy Radio Shack irons that plug directly into the wall. Those will make everyone a terrible solderer. I have the Weller West 51. That's the main iron I've used for most of my soldering, and I like it. It's quite nice, but it's very bulky, so I thought it'd be fun to try one of these tiny ones, see what's going on in the world of soldering irons. Okay, so this looks like it's reflowing nicely. You can tell that it's a small iron, it's a big pad, because when I take the iron away, you can see the solder sort of reach out towards the iron as it's cooling in the air. Like part of the pad is molten and part is cooling, so something to be aware of, that this whole joint isn't uniformly hot. At this point I'm just scooching around the little point of metal, which doesn't feel great. Make sure I don't. So I'm also looking underneath here, the conductor. It looks like it's a little bit of a cold joint. I don't know if you can see that on the camera, so probably out of focus this whole time. Let me try just laying on the heat here. There we go. That feels much better. Still doing this little peaking thing. I swear, if by the end of this I haven't completely destroyed the board, it's a testament to this board's strength. Okay, pull it back out here and take a look. So luckily the trace is still adhered to the circuit board. That's nice. It's a generously sized pad. And that pad looks, the negative pad looks fine, the positive pad looks fine. There's plenty of separation between them, so I'm not worried about shorting. And this is a very low voltage circuit. So let's take a look at the continuity. Got my beeping turned on. So just want to make sure that this is completely attached. I know over here, the positive rail, let's see, comes from, well, it used to come from here, but now we've changed the way this works. So this is the input. I'm just gonna check, see here. Where should I tap this? Everything seems that I want seems to be on the front. Okay, well, we're gonna need to check that it's correctly attached to the circuit board, but first, obviously shouldn't have any continuity between them. That's great. Want continuity into this barrel jack. Excellent. And then I want negative to the outside ring. Can't hold all this stuff at the same time. Good. And then I guess what I can do, let's see here. There's got to be an easy point to test this supply in. Let's see. Kind of follow the trace. So comes down here, goes over to here, it looks like. Try this out. Okay. Okay, so we have good continuity through the PCB. Excellent. And the soldering pads here look, I mean, it's not a great soldering job, but I think it'll do. Cool. So now all that's left is to package this back up and we'll try it out. I don't have a connector for like that will fit this iron right now, so I'm gonna have to find one of those online. But I'll be right back and then we can close this back up, put it back together. All right, it's time to put it back together. So I have the finished soldered unit. I was just trimming the extra solder with some clippers. I've tucked the battery clip back in here. There's two little wires tucked in there. And the solder job, I looked at it a little closer, so it's not my favorite. If you look at the, let's see if I can zoom way in, it's gonna get grainy, but see if I can show you. So you can see on this the red wired pad here, there's a blob of solder and you can see a little plate under it. And similarly, on the black pad, let me use a little flashlight to see if this helps. It's a little too bright, maybe. Yeah, trying to see if I can improve the contrast, but since it's shiny metal, it's kind of hard to see on with the direct light shining on it. So you can see a little bit of a, you can see where the original wire tucks under and then the new wire is soldered on. So that indicates to me that the solder joint didn't get quite hot enough to reflow all the solder, which I don't love. Normally I would insist on having the whole joint reflow and then, you know, make a nice round blob of solder. In this case though, the wires, the conductivity is good. They're mechanically attached. They're not gonna vibrate around really. So I think I'm just gonna put it back together as it is, but so I don't really want to fiddle with the wires anymore, risk damaging the PCB, but it's just something to look at. So let's put it back together. I'm going to start with arbitrarily with one side of the case. We know where the ports have to go, and I'm not going to glue it in this time because I don't think we need to. Originally this wire was just sort of run under, just kind of tucked in here. I'm hoping that we're going to have enough room for the connector and the cables. Let's see if I can run the wires. Let me see how I can fit this in. So there's one approach. I don't really want to crease this too much. Let me start sliding it in and see where it's going to fall. So elegant little construction here that slides together. But again, I don't love the fact that that barrel jack lands right in the middle of the two halves of the clamshell. That seems kind of silly. It seems, I bet they added this hole after the fact, actually. I can't tell if it's drilled out, but I wouldn't be surprised if this is just the USB only version with an additional hole. That would be a nice little cost savings. All right, let's slide that in here. Okay, so that's tucked in. These USB ports, I can tell, are just like a little bit wavy. The sheet metal's a little bent. Zoom in here, which is kind of odd, but maybe these are like leftover old stock or something. All right, so there's enough room in here for me to tuck this cable on top. Like that. And then, or at least I think there is, let's see. Yeah, okay. So I'm gonna slide this out just a tiny bit and a little bit more. Slide this guy back in here. And I'm not going to glue it. Like I said, I don't think we need to. It's an option if you were doing this to re-glue it, but I want to be able to take it apart again without undoing the glue. So I have this is a little bit different cable routing than the original. I have or wire routing. I have the wires coming over the top of the PCB. You can see where they're soldered under there. Nice that we can check on them a little if we need to. They come around the front, behind, right beside this nut that holds it onto the panel. And then you can see a little crease in there where the red wire is folded. But this is not going to be vibrating or moving around a lot. So, or it's not going to be, it might be vibrating, but I'm not going to be bending that wire back and forth a lot. So I'm not too worried about creasing it. Okay, and then slide the other case half on here. The PCB tucks into this little slot. What am I missing here? Where is this not aligning? Ah. Oh, I wanted to take a look in here while we're in here at this clip. So it looks like the clip actually isn't anchored. So it's a full width clip, but it's only anchored to half of the shell, which is, and then on this side we have the sharp, this is like a knife. Wow. And you can see that it's an uneven thickness. It's a little translucent in an uneven way. So don't love that mold design. It's kind of bizarre. They could have chosen one side to hold the clip completely and made it come over the halfway line. Oh, I see. The clip is preventing this from sliding together. Okay, so here we go. And when we took it apart, it was a pretty tight fit. The clip is sprung down, so it's preventing it from sliding on without a little bit of pressure. And it looks like it's misaligning. Let me see if I can try this again. I see. So the PCB actually goes, so the PCB isn't retained by this clip. It's actually below it. This clip is what retains the yellow plastic piece. So on this side, there's a little inset holder for the PCB, a little ledge. On this side, there's just a lack of plastic where the PCB should go. So it's a little bit different. If it's true on the other side as well. Yeah, okay, so the shell kind of holds the yellow plastic up off the PCB. That's interesting. All right, so this was tight when we pulled it apart. I expect it to be tight when we put it back together. I want to make sure the wire's not pinched. Looks fine. Let's see if we can push it together. So it's a little springy. I feel like I'm crushing something. Might be. And maybe we'll discover why they glued this. It doesn't fit together very elegantly. I'm going to see if I can push the wire in just a little bit more with the screwdriver extension here. Ooh yeah, tuck it back in there. Okay, that feels pretty good. I think it's unencumbered here. So, screws going back in. We just have our two plastic screws with the Phillips heads. That does not feel like it's threading. Let's see if I can get that down into the other half of the mold. Something. Ooh, it's not even settled. Let's see here. There we go. All right, seals up nice and tight, and this jack isn't moving at all. I'm not sure why they glued that originally. Maybe just a little insurance policy, but I don't think it needs glue. All right, looks good. Okay, so everything's screwed back together. This little yellow piece floats around in here. It can wiggle side to side. I think that's normal. Okay, so just as a sanity check, we're about to plug this into a lithium tool battery. So I'm gonna make sure that these leads aren't shorted to each other, just to be extra safe. Okay, seems like an open circuit, which is good. All right, so like I said, I don't have the barrel jack for this yet, so we won't be able to test it with the soldering iron, but we can slide it on the battery, see if it explodes, hopefully. Ooh, do I really want to do that? This is a lot of power, but we just moved something over. I'm pretty confident there are no short circuits in here. All right. Nothing smoking, nothing too hot. So bring in the voltmeter again. This time we should be seeing the open circuit voltage of the battery rather than a regulated output. So I'm gonna put one in again on the ring here. This is like playing a game of Operation. You don't want to short the output here. And let's do the center. And that is saying overload for some reason. I have it on DC, auto ranging. That is odd, because it's certainly not more than this meter can handle. What's going on here? We're in range. Let's go up. Interesting. I'm going to connect one into the housing of the USB connector, which is also ground. Huh, what is going on here? So we're on DC. Let's go up even higher in the range. Oh, there we go. Okay. I don't know why it's not auto ranging to find that. 18.2 volts. Perfect. So we have the raw output of the battery on the barrel jack. No short circuit protection. So hopefully the battery has some kind of protection against over discharge. I'm actually not sure. Like, you want the tool battery to be able to provide a bunch of current when the tool needs it. So these are pretty beefy. Similarly, we wanted to provide a lot of current to the soldering iron. So it's somewhat a feature to just dump the battery output onto this jack, but it comes with some risk. We saw the regulation circuit in there for the USB ports. I'm mostly interested in the DC port for this one. The USB ports on here would be worth trying, but I'm going to leave that for a future video. So anyway, there's the mod complete. I'm going to use this for the TS100. I'll make a follow-up video when I get the cable for the TS100, including the barrel jacks. One thing I do like about my Weller soldering station is that the cable is a heat-resistant silicone. And when you bring your own cable, like the one I was using from my internet modem, it's usually just a vinyl-coated DC cable. So that'll melt if you accidentally touch it with a soldering iron, and it'd be nice to find some silicone cable. So I'm going to try to find some if it's reasonably cheap, and it'd be silly to spend as much as the iron, as much as you spent on this iron on the cable, but part of why this is cheap is probably because it doesn't come with the heat-resistant power cable or the power supply. You've got to bring your own. So in cases like this, I already have these batteries. I think this will be cool as a mobile soldering solution, but I got to find a cable first. Until then, thanks for watching.